That'd be good. All right. So where we left off with assignment 1, we just had a scene that we had modified. We added in some new sprites. So in this case, I added in a character sprite already. And you can see it's my little stick figure. And right now the stick figure, it's just an image. So if you remember from our prior discussions, the way that we define what a game object is depends upon the components that we add to it. So right now it just has a sprite renderer associated with it. So we're going to build this out more such that now we can turn it into a game object that the player can control. And so I've created this assignment 2 uni package to get you all started. So I've already downloaded it, and so I just need to load it into the game. And so if you come to Assets and Import Package, we go to Custom Package. If I go to Downloads, I have Assignment 2. And so it's coming up and saying, here's a scripts directory that's now being added. It has these 3 scripts associated with it. This camera follow script, character controller script, parallax script. Do what?
Just open not so I have to open up before I see by itself again.
Yes. So you'd have to open up the project, and then if you come into Assets and Import Custom Package, or Import Package and click on the Custom Package, that'll bring it into the scene that you've already been working on. So I'm just going to say Import. Okay. And so it creates these, so you should have a scripts directory created in your project, and you shouldn't have this script is something that I wrote. It's not part of it. You should have this camera follow, character controller, and parallax. So before I open up one of these scripts, if you come into Edit and Preferences, if you look at External Tools, you'll have an option for this External Script Editor. And so by default, you should have something like ModelDevelop. So Unity provides ModelDevelop. For Windows users, you can also use Visual Studio. I believe Mac users, now there's a version of Visual Studio available. So it's really kind of a point of preference which one you want to use. Given that I'm in a Windows environment and I've been using Visual Studio for quite a while, everything I'll do will be through Visual Studio. ModelDevelop is fine to use. There really isn't much of a difference between the two regarding the functionality that we're going to use in class. But I say just because I use Visual Studio on a day-to-day basis, that's the one that I use for this. So you can choose whichever one that suits your preference. Because I know there's some, if you're following tutorials online, some folks use ModelDevelop, and then others use Visual Studio. And that's just the way, if you want to set your editor to correct whichever one you want to use, that's the way to do it. So I already have it open. I'm just going to close it just so you can see it open up. So I'm going to open up Character Controller because really what we want to do is start building up the functionality for the character.
So where do we make the character then?
So how do you make the character?
There's no character that comes with the assignment 2?
No. So it's either if you've made a character already from your prior assignment, you can use that. Otherwise, you need to find a sprite to use. So you can either find something online, or if you want to draw your own through something like Piskel, you can do something like that. Also, we're not animating things right now. So the animation, we're going to get into animation in the 3rd assignment. So it really just has to be a static sprite for right now. So when we get to the third assignment, we'll start getting into how do we load in animated sprites, and then how do we tie those sprites to the player movement, so then you can actually have a visual representation of. So yeah, if you get like a Visual Studio, do you want to sign in? You should be able to skip that. So, or if it doesn't have an account, you can sign up. So if you want to use Visual Studio, you can sign up for it. Otherwise, you can also change over to Model Develop. That doesn't require any kind of sign up to do. So let's see.
Web development or just general development?
Just general development. Let's see. Can everyone see the text okay on this? Or is it a little too small? Okay. So should be. Here we go. We'll close that. Change some of this around. So I'm going to explain more of this on Thursday, kind of what the structure is. For those who have done some programming previously, we're going to use C# as a language as opposed to JavaScript. And C# it's an object-oriented language, and it's also a typed language. And so what that means is we define everything in terms of classes. So in this case, we have a class called character controller 2D, and then you have this colon and this thing called model behavior. So any script that you want it available to be seen as a component in the editor, you define it as a model behavior. And then model behavior also offers a host of other functions that you can tie into, and I'll explain a little bit more how this works as it goes on. But this gives all the different code, or all the code that's required for the character controller. And if I scroll down, so up top here, these are different variables that I've tagged as, it's called serialized field. And so that will make it seen in the editor. And so if I come back to character controller, and so here's my character, and if I want to add this as a component onto my character, I can just drag it over here, and now it gets added on. And so the values that you saw at the top, this max speed, jump force, air control, what is ground, and run multiplier, those are all variables that are defined right here. And then there's a host of other variables. These are all private variables. So the part that y'all be interested in is where is it that I actually have to code stuff? Because most of the functionality is already provided for you. So here for assignment 2, this is where you need to add the code to check for player input. So being able to set the jump and move variables. So these two variables based upon the player input. And so everything else with regards to actually moving the player around, that is already provided for you. And the way that we're doing that, if I dive into the move a little bit more, you have this rigid bot. So there's this variable called rigid body. And so in Unity, Unity provides a physics engine for you. And so because it has this physics engine, you can then tie a physics component to your object and then apply forces to it. So how many of you have taken like a physics class? Some of you? Okay. So for those who didn't, this is going to be sweet because you're actually going to learn a little physics while you're doing this class. So if you remember from physics, especially if you're just doing kind of like 2D Newtonian physics, we end up using vector math, so vector addition, vector subtraction, in order to apply forces to get things to move in certain directions. And likewise, we're doing the same thing with our characters in that we're applying a force or setting a velocity to get objects moving around. So that's what's happening. What's happening within here, and then we're doing checks to see if we're facing the correct direction, or if we need to flip the sprite. So for anyone who's making a sprite for your player character, you want the sprite to start out looking to the right, and then what will happen is if you press the right button, it'll move right, so it looks like it's heading in the correct direction. And likewise, if you press left, you can flip the sprite, and then it'll come back and look and appear to be moving to the left. So anyway, in order to get this to work, so I've said that we need to have a rigid body. So that's something that we have to apply to the character in order to access that component. So if I come to add component, what I can do is I can start typing in. I started typing in rigid body, and I get rigid body 2D. That's the one that I want. And then within rigid body, you get a host of different parameters available to you. So you get things like mass, drag, gravity, and so you can alter those. And so as you apply a force and start moving the character around, it'll take those into consideration when it's determining how to move it. And once you start moving the character around, I'll show you how you can tweak those to then see kind of variations in movement. So another part we have to do as well for this assignment, it deals with the jumping. So we have to know when a character is on the ground versus when they're in the air. And so we need to know when when the character is collided with the ground. And once they're collided with the ground, we can say the character is sitting, and then if we press the space bar, we can jump. And then we do another kind of collision check to see whether or not if they're in the air, then we disable the jump button until we get back down to the ground. And so that's where this fixed update. So fixed update, this is a method that Unity provides as a default model behavior. So like I said, our class extends model behavior. And so within model behavior, you have functions like awake and fixed update. And so they define those, and so we're writing what those should mean, what should happen whenever those are called. So in fixed update, so this gets called on every update loop for the game. And so we'll explain more in the later, probably next week, kind of how game engines work, and when we talk about update loops or simulation loops, kind of what's happening, how this ties into Unity. So for right now, just know that as the game is being updated, it's calling this at a prescribed rate. And so what it's doing here is that it's looking to see whether or not there's this ground check. And so ground check gets defined at the start of the game. So when the object wakes up, so awake happens whenever it's enabled, the game object gets enabled. It looks to see whether or not you have a ground check on your type of your character, and then sets that variable, and then it uses it in here to then see whether or not that ground check is colliding with the floor. And so really what we're doing is, so we're going to create a character that has one big collider around it. So then we know if we're running into walls, running into enemies, and things like that. But then we're going to create something that you put really kind of on the feet of the character. So then you can say, based upon that point, is my character's feet or their local, how they're moving around, is that touching the ground? And if it is, then we can say it's grounded. And if it isn't, then we can assume it's in the air, and we can change the behavior and how all that works. So it's kind of a lot to throw at you right now, but let me walk through kind of how to set some of this up. Maybe that'll help kind of clear this up and make a little bit more sense. So let's start with just getting a collider around the character. So do what?
Try and add add a picture of the character into this.
Okay. So is that what kind of file is that?
It's just as an image.
So I believe you can get like a PNG. I don't think Unity handles JPEGs all that well.
There we go. Here's something.
Okay. There's other. Let's say if you want just something to play with for now, if you go into sprites and forest, and you grab something like the wood block, you can use essentially use a wood block as your character rather than anything else.
Well, that makes sense.
And so if you were to do that, you would need to set it such that the sorting layer is on the foreground. You can change the ordering layer such that it is more prominent. So I'll leave that in there so then you can see.
So if I select this, I have to drag the character controller over.
Right. So you can drag the character controller. Yeah, so I can actually show you. I'm going to remove this. I'll just disable it for now. I'll make my wood block my character. So I'm going to rotate it so it looks like it's standing up. Well, not. Oh, let me rotate it in the Z. Just so it looks like it's standing up. There you go. And then, so I can add a character controller to it. I add a rigid body. But now I want to add a collider to it. So I'm going to add this, so there's a number of different colliders that Unity provides. So we'll start with the basic one. Actually, so you can do box colliders. For characters, I prefer to use a capsule collider. And a capsule collider, you should see this green circle now around it. And so this green circle represents the collision area for the character. So a collision will be detected once this green circle intersects with another object that has a collider associated with it. And so it's a little, so there is quite a bit of open space. So you can see here, it kind of extends outward. If you want to futz with it, you can do something like press edit collider, and you can start kind of moving things around. Because it's a capsule, it's going to keep that kind of capsule shape to it. If you want to get fancy, I can remove this. We do something like polygon collider. And so polygon collider, this allows you to create an n-sided polygon. So you can actually draw something that follows the contours of whatever character you're putting together. So I can come in here and move things around. It's a little hard to see. But you get the idea, right?
I'm just trying to find out how to do the rigid body.
So to get to rigid body, so rigid body, you go to add component, and then you start typing in something like rigid, so like RI, rigid. Yes, and you want the 2D version because we're not applying. So if you did the 3D if you did rigid body, that's for 3D environments. And so because everything is 2D, we'll just keep it as 2D.
Unless you want to put a 3D character in a 2D thing.
Right. And so, so we'll talk a little bit more about colliders later on. Kind of what are the advantages, disadvantages of using different ones. I'm going to remove this. I'm just going to keep it as a capsule collider for now, just for the sake of simplicity. But you are free to use kind of whichever collider you want to apply to do this. So that gets us at least just a collider. So we now know if our character is running into something. And now what I want to do is I want to add on that ground check. So I want to have something that defines kind of the bottom of my character so that I know whether or not it's on the ground or it's in the air. And the way that we have it set up in the script, if I go back and reference the script, it's doing this transform find. So it's looking to say, does the object that I'm attached to, does it have some child object called ground check? And if so, I want to grab it and save it in this variable. So we need to create a child object called ground check. And so if I come back, so I'm going to change the name of the wood block because I want something a little bit more descriptive. I don't know. Let's call it Woody. So I'm going to add the Woody. I'm going to make an empty. So if I just right click on Woody and I go create empty, it's now created an object that is a child of Woody. And so by being a child object, what that means is the position. This is now the position and rotation are now relative to the parent object. So if I come back to my move tool, so the move tool allows us to kind of grab and kind of move in space, where this is going to be. So, if I grab the arrow, I can move it around, or I can move it up and down. And really, I want it, let's say, kind of toward the bottom. So you can see something about right there. It'll probably be okay. And now I need to call this ground check because that's what in our script, that's what it's looking for to find that object.
The letters in the word have to be exact.
Yes. So the case has to match. So capital G, capital C. And you see the position. So this position, it's a relative to our parent object. Okay. So now if I come back, so I'm going to look at this code a little bit more. So now I have this ground check. I have a collider associated with the character. So let's look at this a little bit more. So on every update cycle of the game, the game's going to start off, it's going to set the grounded flag to false. So we're going to assume right now that the character is currently in the air. And then we want to make a check to see is the character actually on the ground. And the way that happens is that we do a call to Unity, this physics 2D, and not to explain this in sickening detail, but what it's doing is that it's getting the position of its ground check, and then it's seeing within a certain radius, is that touching an object that's on a given layer? And if it is, then it's going to come back and give the list of everything where that that circumstance is true, where the ground check is touching something that has a particular layer. And then if we find it, then we're saying, okay, then we're saying that the character's on the ground, and then this jump count. So I'm saying, and we'll get into jump count when we start talking about double jumps. But this is kind of the important one right here, is just to say the character is actually on the ground. And so anytime you come across something where you don't understand, you want more information about the class or the function, if you come up to, I just kind of clicked on it, but every component has this little help book, and if you click on it, it brings up the Unity manual that gives you information on the API. And so I clicked on the transformer one, and so it goes into an explanation talking about what the transform, what are transforms, what are the different properties of transforms. And so this becomes useful, especially when you start really getting into the scripting side. If you want to learn it, if you're trying to find out what particular components are, or like I said, we have this thing like physics 2D. It's like, what does this class do? What is this all about? I can come back and search the manual and say, give me information on physics 2D. Maybe I need to go to the scripting API and switch over there. Or maybe it's just running incredibly slow. So normally this would work, but I think maybe it's just kind of for some reason. Oh, there we go. So if I click on physics 2D, so now it's telling me what the class is. So this is for global settings or helpers for 2D physics. So it has a set of properties, it has a set of methods. So the one that we were using was overlap circle. So then it gives you some more information about what it does. So it gives a list of all colliders that fall within the circular area. So I said the Unity API, it becomes immensely useful. I mean, this is not only just for this class, but any tutorials that you want to try out, and they talk about things within the scripts that you're not quite sure what it's doing. You can always come back to the Unity documents to then go through and figure out what some of these functions are, what some of these classes are. So coming back from that tangent, so if we look at overlap circle all, it takes 3 parameters. So one is the point that we're interested in, which is going to be our ground check. The size of the radius, so how, within what area do we want to check to see whether or not it's colliding with something. And then there's this this last parameter deals with what's called a layer mask. And we have this variable that we call what is ground. If we come back to Unity, so every object, so at the very top of the inspector, you've probably seen some of this stuff. So you have the name of your object, then you have this check. And so you have an experiment with this already. So this check tells you whether or not to enable or disable the game object. So if you want it temporarily disabled, you can check it, it disappears. So once it's disabled, that means the game object is no longer being updated within the scene. And so that means any of these scripts that are components that are attached to it won't run. So you can enable and disable it. And then you have this tag and layer. And so this is a way that you can organize objects within Unity to quickly find them within scripts. And so you're using it to just kind of group things together so then you can easily query it. So it's nice for, let's say, if you're trying to kind of find, we already have a bunch of objects in our scene already. So if we're just trying to find things that are ground, so instead of us checking every object to see, is this something that the player should be colliding, is this something that the player should be colliding with and interpreting it as the ground? We can just go ahead and define what we're saying is our ground layer. So under layer, if I click on that, you can see it already creates some default layers for us. If you come to add layer, you can add in your own. So I was playing around earlier. I added in ground. But I said you can kind of add in your own. I would suggest using ground, but you can define it as whatever. And so now if I come here and click on layer, you now have ground as a particular option.
How do you just go to add layer?
Yeah. So you go add layer, and then you can type in. You can say, I just named it ground, but you can have ground, sky, lava. Yeah, you can have a bunch of these. And then when you come up and click on layer, now you have those all defined as well. But what we want to do is set up such that anything that we want the character to stand on is ground. And so for those who are utilizing tiles, if you remember that the foreground, these are all prefabs. So the nice part about prefabs is that if we change a value in the prefab, it updates that for all game objects that are out there.
Do we want the ground check as the ground layer, or do we want the character itself in that layer?
No, we want the things that we're calling ground defined on the ground layer. And so here I can select all the different tiles and then define that as ground. So I did that previously, but just to show you what's happening. If I said I'm going to define it as lava, and then if I come back and click on any of the tiles in the scene, you can see they've already been identified as lava. Well, so I want to keep them all as keep them all on the ground layer. So now they're all defined as ground. Then coming back to our character, so in our character controller, we have to identify the layer that we're saying that we have this variable the same. We want to know what we're defining as ground. So if we click on here, we want to check the ground layer. That is what we're calling ground. Okay. So let's start. So if we were to run this right now, I wouldn't see much of anything. You see my character sitting there. But one thing you want to pay attention to is this console. And the console becomes important because this tells you if something breaks during compilation or during runtime. And so right now it gives us these warnings, so it's not really much of anything to be concerned about. It's telling us that there's some scripts that it's trying to read but can't find them, but it's not holding up the game. It's still allowing the game to run. If I were to come back to our script, So if I just started typing in something, so if I just said something like jump equals, and then I'll close that. So in C# we close lines by having a semicolon after it. So if I just leave this kind of hanging out here, and I come back to Unity, so now Unity's throwing up an error saying, hey, you can't interpret this. So some of the errors you get may look cryptic, but it's telling you on a given in which script file and what line is it seeing something that it doesn't understand. And so, so I said, so this will help you out as you're coding stuff. You'll want to check before you start playing whether or not you have anything in that console that's a red flag. Because if it is, then the game's not going to run. It's going to want you to fix that first before you can get to play. So I'm going to start. So we have kind of everything set up for what we need in order to get the characters to move, or get the character to move. So really we just need to put in the controls to actually make it happen. So I'm going to start getting into some of the actual scripting that's required. So like I said, for assignment 2, we need to add in the code here to do the player input. And so for jumps, so I'm going to take out this line for right now. So I'm saying, so in here, we can only jump if the character's on the ground. So if mGrounded is equal to true. And then we may allow for a double jump. And that's where this jump count comes into effect. I'm not going to worry about doing the double jump right now. Right now I'm just going to play with just getting a regular jump going. So if I come back to our Unity scripting, if I search for input, so interface into the input system. So there's a class within Unity that allows for whatever script you're looking at to check to see what a user's doing at any given time. So are they pressing keys? If they're pressing keys on the keyboard, which keys are they pressing? If you have a joystick set up, are they using the thumbstick? And if so, how much they're pressing it, things like that. It also applies to mobile devices too. So the nice part about Unity is that you can build this out to various devices. So you can do, you can do checks like taps on the screen and things like that, and be able to access it. The things that we're going to be interested in are these two methods: is get access and get button down. And so, get button down, what that refers to is that whenever a user presses on a key, so the moment they press down on it, that's when you want to tell whether or not the event's happening. So it's not if they're holding the key down, it's just that instant when they press it. And likewise, this get button up, that's when they lift their finger off the key. So if you want to do something, say like a fire, you could do get button down and just check every time they tap. Or if you want to have it where it just automatically fires when you hold it down, you could do something. Yeah, like an automatic gun.
Or the rifle, pop, 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 or a machine gun.
Yeah, so you could do get button, and get button's just going to say, is this button being pressed or not? So if it's being held down, then you could say, this is happening. So button down and button up, that's just the instance when, the moment when it first gets pressed and first gets released, and then get button's just when you hold it. And then get access, this refers to, that is what they call these virtual axes. And where they define those, you come into edit and project settings. So here you have a number of settings. In this input setting, it sets these different axes. So they have a horizontal, a vertical fire. And so this is just kind of so it's a different way to get kind of the same result. So instead of having to check, so for instance, for our movement, we want to know whether or not the users want to move the character left or right. So we could do it by checking both those keys. So see if they're pressing the left arrow key or the right arrow key, or if they're pressing A or D. But you can also come into here for horizontal. So the horizontal axis provides a negative button, a positive button, so left, right, A, D. So you can define all those buttons here, and then just check to see. You can check the axis, and then it's going to look to see if any of these buttons are being pressed. Now, because we're talking about buttons, so a button can only be in two states, right? It's either it's not pressed or it's pressed. So the values that can come out of this are only going to be two values. So 0 is nobody's touching that button, or 1, somebody's touching that button. But there's a third value. So you get to that by going to Edit, Project Settings, Input. And so if you're pressing the positive button, it's going to return a value of 1. If you're pressing the negative button, it's going to return a value of -1. And if you're not pressing it, it's not going to return any value. So likewise here, we have a jump. And so this may or may not be defined for you already. So you can create, so you may look for a jump, and then you can set it to the space, or you can set it to, alternatively, so we can set it to the W key. So if I wanted to use WASD, I want that as the alternate positive button. Because I want it to go upward.
I thought the button says joystick button 3.
Yeah, so it's good to, let's say you can do it to space, or have the alternate button be W.
Positive means you want something to go up.
Right. So, or well, what if that button is being pressed, we're going to return a value of 1. And likewise, you have this negative button, which means return -1 if that's being pressed. So for jumps, we just want things to move upward in the Y direction, so we'll use the positive value. The reason we use the negative values here is that to move across the screen to the right, we apply a force in the positive direction, so that goes right. And likewise, if we press the button for going left, that means we want a force in the going in the opposite direction, and so we make that a negative value. So let's say jump. So if I say input get button down, and so the button we've already defined as jump. And so what am I doing here? So right now this is going to return, so jump is a Boolean value, so it's either true or false. So get button down, if I highlight it, it says it'll return true the moment during the frame when the user pressed down on the button identified by button name. So when they press what we're calling the jump button, so either they're pressing space or W, this will return true. So we want to, and like I said, the caveat is we only want to jump on the characters on the ground. So when this is equally true. So we can say if this is true and this is true, then we'll go ahead and set jump to true. So if either of these are false, so if the player's not pressing the jump button, or if the character's in the air, then this is going to return false. So we'll talk more about conditionals on Thursday and kind of how that works. But for now, just kind of leave it as is. So if I come back to the screen, let's see. So right now,
Can you go back to that real quick?
sure. So you don't have to worry about trying to like follow in real time. Like I said, the whole reason we're recording screens and taking audio is that you can look at this at a later time as well.
Do we need to hit enter after we put in that semicolon?
Not
That's what you did.
necessarily. You don't have to. That's how you finish a line within C#. So now if I hit play, whoa!
Don't hide.
So, yeah. So maybe a little too much mustard on that sandwich. So the nice part about Unity is that with the component viewer or the components inspector, you can change these values in real time or as the game is running to then get a better sense. So right now, I said that was a little too much. So if I reduce the jump force to say half, so if I take it down to say 200, it looks a little bit better. And you can tell, well, it's kind of hard to tell, but if you listen, if I hit my keyboard, so it's only jumping whenever the character's on the ground. It's not trying to jump.
Not double jump.
Right. So just to show kind of what would happen in code if we didn't do that. So for instance, if I just check to see, am I just pressing the key, I'm going to dial this down to, say, 100 to start, because you can see if I didn't do that ground jump, that ground check, it would keep trying to pull it up and up. So I'm going to come back, just undo that, just leave that as is. And so just quickly here, just to get the character moving left and right, you can say move. You go to input. It's going through the earth.
Yeah, as soon as I hit the start, it just goes.
So it could be that there isn't a collider on the tiles that.
Collider?
Yeah. So if if any of your tiles don't have colliders, if your character doesn't have a collider.
How do you do that?
So this
You
can.
want to do it Thursday?
Sure, we can look at it on Thursday, but anything that your character collides with, so your character needs a collider, but then any of the ground objects need a collider as well. So that tells
we need that box for okay.
when it's hitting. Just to quickly kind of show. So this get axis horizontal. So get axis. So this returns a float value. Like I said, so it's either going to say left or so. If I press the right key, it should return 1. If I hit the left key, it should return -1. If I'm not touching it, then it should be 0. And so it's compiling. Whoa!
What?
So it's Yeah, so
What happened?
it's rolling over itself. And the reason being, I can tell you why. I usually forget to do this. So for rigid bodies, you want to freeze the rotation on the Z, because if you don't, then when you
like a cannon.
yeah, well, when you apply a force, that collider is just gonna, it acts more like a wheel, so then it just starts rolling rather than.
Like it was a punch.
Yeah. So now, now by freezing in the Z, whoops, did not. I think I buried it in the ground somewhere. Whoop.
Now what
A
happened?
little too fast. So probably a little too much force on the speed of the character. Like I said, you have, because the values are exposed, you can come in there and play and try some of these different values. So let's say we're kind of out of time right now, but we can pick this up. Probably need to pick some of this up on Thursday. So
After the quiz.
Or probably before. I said probably do it all before the quiz.
Okay.
But you should have enough to get started just with doing a little bit of the scripting, setting up the scene. But I'll get this video posted as soon as I can. But this should get you started, and then we'll continue on kind of showing how to then apply the camera follow and the parallax. So then you can have the camera follow the character as you move around, and then get kind of a neat parallax effect with the images that we have set up here. So that's all we have for today, and then also remember quiz Thursday. So be prepared for that.